YouTube? This is your boy Network Prodigy. Welcome to a Whiteboard Friday, where every Friday I'm gonna pick a specific technology, I'm gonna draw it out for you guys, and we're gonna talk about how it works. So the technology we're gonna talk about in this session is Hsrp, or the Hot Standby Router Protocol. What Hsrp is designed to do is give you fault tolerance at layer 3 with your gateways or your routers. So if you're using one router as your gateway, if that router happens to fail and become unresponsive, you can automatically fail over to the other router, start using him as your gateway, and you don't have any operations go down or anything like that. So let's whiteboard this out so you can see exactly what I'm talking about. So here's your local area network down here, or your LAN. Now you're going to have two routers connecting to this LAN. Here's router 1 and here's router 2. Okay, both of them connect back to the LAN. Now they're each going to connect to ISPs, however different ISPs, because if one ISP has problems, you want to be able to fail over and start using the other one. So one is going to go to ISP A, 2 is going to go to ISP B, kind of like that. Now here's your PC down here who's going to connect to the LAN. Now you're trying to get out to the internet, right? Well, you got two routers right here that can serve as your gateway to allow that to happen, but only one of them can be your gateway. Let's just say it's router 1. So traffic starts flowing this way through router 1 up to ISP A. That's how you get to the internet. Now, if router 1 experiences a failure, we don't want the computer to keep trying to send traffic to router 1 when he's not on the network. He's not responding. If you keep trying to send traffic to router 1, you won't be able to get out to the internet. What we want to happen is we want your computer to automatically fail over to router 2, start sending traffic this way so he can still get out to the internet. And again, we want this done automatically, meaning I don't want to have to log into this PC and change anything, right? Because this could be an end user, like one of our employees. We don't want them to have to do anything. We just want to stop sending traffic to router 1 because he's no longer available, start sending traffic to router 2. That's what Hsrp is designed to do. So let's talk about how this works with Hsrp. So you got two routers. One of the routers in Hsrp is going to be what we call the active router. And his job is real simple. Take the traffic in from the devices that's trying to get off the LAN and communicate with devices elsewhere and route the traffic, forward the traffic where it needs to go. Now, only one router can be active. Okay, the other router is going to be the standby router. Okay, he's just kind of sitting back, chilling in the cut, as I like to call it. So he's pretty much not doing anything. He just needs to be on alert in case the active router fails or becomes unresponsive. He can then promote himself to active, and then devices can start routing through him. So let's just say router 1, he's your active router, so he's going to get all the traffic. 2 is just sitting on standby in case router 1 fails. So this PC down here is going to send traffic to router 1 in order to get to the internet. But if router 1 fails, router 2 can promote himself from standby to active, and now he can start sending traffic to router 2 in order to get to the internet. And all of this is going to be done automatically without you having to change anything on your PC. All right, so you're going to have one router that's active, one router that is standby. So let's kind of talk about how they determine who becomes active and who becomes standby. So when you enable Hsrp on these routers, they're going to start sending hello messages back and forth between each other so they can discover each other, right? Inside of these hello messages, each router is going to have a priority value, which this priority value can be any number between 1 and 255, but the default is going to be 100. So if you enable Hsrp on these routers and you don't change the priority, they're going to have a priority of 100. How it works is whichever router has the higher priority, that's the router that becomes active. So whichever router you want to be active, you simply give him a higher priority. So we want router 1 to be active, we can give him a priority of 110, and leave router 2 at the default of 100. Now router 1 is active, router 2 is standby. Okay, so now we have our active router and we have our standby router. What's going to really make all of this come together though is what we call the VIP, or what we call the virtual IP address. So the VIP is going to be some IP address that is shared between the routers. So we know on this LAN segment down here, we're using some type of address space. Let's say it's 10.0.0/24. Okay, so every device connecting to this LAN is going to have an IP started with 10.0.0 in the first 3 octets. So maybe router 1 is 10.0.0.1. Router 2 is 10.0.0.2. Now, you also need an IP address that you're going to use as the virtual IP that's shared between both of them. So it doesn't belong to either one of them. They're sharing it. So let's just say the virtual IP that's going to be shared between them is 10.0.0.3. Okay, so the VIP has to have an IP that's in this subnet as well. So you can see his started with 10.0.0 in the first 3 octets. Now, here's how it works. Even though they both share this IP, only one of them can respond to traffic destined to this IP. So for example, this PC down here, if he sends an ARP request for the VIP, it's going to go to both router 1 and router 2 because an ARP is a broadcast. But since router 1 is the active router, he's going to be the one responding to the ARP. 2 is not. Okay, so only one router can respond to traffic destined to the VIP. That's the active router. And when these PCs down here or these devices connected to the LAN start sending traffic to the VIP so they can get to the internet, for example, it's only going to go to the active router. It's not going to go to whichever router is standby. So here is how everything comes together. Your PC connects to the LAN and he's going to get a couple of things. He's going to get an IP address. And it's going to start with 10.0.0 in the first 3 octets. So let's just say 10.0.0.20. He's then going to need a mask, which we know is a /24. So it's 255, 255, 255, 0. Now he needs the IP address. Make sure I write that clearly. Now he needs the IP address of his gateway. And when you're assigning the IP, you don't use the IP address of router 1. You don't use the IP address of 2. Instead, you use the IP address of the VIP. So the IP of your gateway is 10.0.0.3. And that's it. So your PC gets this information. He tries to get onto the internet. He's going to send an ARP request for this IP right here, trying to get the MAC address. It's going to go to router 1. It's going to go to router 2. Which router is going to respond to the ARP request? It's going to be the active router, right? Which happens to be router 1. So he's going to respond to the ARP request with an ARP reply. It's going to have the virtual IP, which is the VIP, and it's going to have a virtual MAC address. And when we get to a lab, I'll show you what that looks like. So now the PC down here, he's going to know, just clear that, he's going to now know how to send traffic to his gateway. So when he's trying to send traffic to 10.0.0.3 in order to get to the internet, put this in a different color, traffic is going to go this direction. It's going to go to router 1 and then up to ISP-A. Now, let's just say router 1 has a failure. He's no longer responding on the network. Now, router 2 is going to know this because they don't just send hello messages to determine who's active and who's standby. They're also going to send hello messages just to make sure the other router is still there. So if router 1 goes offline, 2 is going to know this because he's going to stop getting the hello messages from 1. If that's the case, 2 is going to promote himself from standby to active. Now anything that is destined to 3 or to 10.0.0.3, since 2 is active, it's going to go this way. It's going to go to 2, and 2 is going to send it to ISP-B. And this is going to be done automatically, and we don't have to change anything on the PC. He's just going to stop sending traffic to 1, and it's going to start going to 2. Because previously, 1 was taking the traffic destined to the VIP because he was active. But now that he's offline and 2 is active, now 2 is getting traffic destined to the VIP. That's how the dynamic failover occurs. Now, let me ask you this question. Okay, so we know that 2 was the standby. Router 1, red, went down. 2 promoted himself from standby to active. What happens then when router 1 comes back online? Right, so let me kind of go back. All right, so now router 1 is back online, but 2 has promoted himself to active. Remember, only one of them can be active at a time. So what happens is, by default, even though router 1 has a higher priority, since 2 is already active, 1 is going to be standby. Okay, he'll become active again if 2 has a failure. But there is a feature you can enable called Preemption, where if you enable Preemption on router 1, when he becomes available again, he will overtake the throne, as I like to say. But essentially, he will become active and 2 will go back to being standby. But that only occurs if Preemption is turned on. If it's turned off, 2 will remain active, 1 will be standby, even though 1 has a higher priority. But ladies and gentlemen, that is how Hsrp works. Okay, all you're gonna do, turn Hsrp on. One of these routers is going to be active, 1 is going to be standby. You tell the routers what the virtual IP is, and this is the IP that you make your gateway for your clients. And then any traffic that's going to the VIP goes to the active router. So right now it's going to 2 because we didn't turn Preemption on. So all that traffic is going this way. But if 2 ever fails, right, 1 is going to promote himself from standby. He's going back to active. Now traffic to the VIP goes this direction. And the key is, all of this is done automatically. You don't got to make no changes to your PC. As a matter of fact, you may not even know that any failure occurred because it just automatically fails over. Ladies and gentlemen, that is Hsrp. Now what you want to do is stay tuned for Configuration Tuesdays, because what we're going to do is take a look at how to configure Hsrp. We're going to take a look at 2 failure scenarios. How does it look when you don't have Hsrp configured? How does it look when you do? So be on the lookout for a Hsrp demo on Configuration Tuesdays. See you then.